So just a quick introduction. My name is Ryan Fee. I'm the Director of Solution Architecture here at Scalr, and I want to thank everyone for coming to Scalr's first Terraform and automation collaboration webinar, otherwise known as a TACO webinar. Today, what we're going to do is give a brief intro into Scalr, some of the basics of how to use Scalr and what Scalr is. That's going to be the first part of the webinar. Second part of the webinar, we're going to talk about how you scale Scalr for your organization. So we're going to have two demos today, like I mentioned. The first demo is going to be more around GitOps and how to plug it into Scalr. Going to be a very basic demo, just kind of set the groundwork for what Scalr does. The second demo is going to be more so around scaling Scalr for your organization using the Terraform CLI and Scalr Provider. So that first demo we're going to do is going to be using VCS-based integration or VCS-based runs. The second demo is going to be CLI-based runs. The reason for that is when we look at when we look at our metrics across our customer base, it's actually a 50-50 split between the two types of runs, so CLI or VCS-based runs. So a lot of customers come to us, when we have our first interaction with some of our customers, and they come to us and say they've outgrown some sort of process that they have in place. That could be Atlantis. It could be they have GitHub or GitLab actions built out to interact with Terraform and build out Terraform. It could be that they have the CLI plus some other tooling in place, or they built a homegrown tool or homegrown taco, as we like to call it. So a lot of those use cases come to us, but they say they don't want to change their developer experience. So the developers are happy with how they're interacting with Terraform. In this case, maybe they're happy with their GitOps approach. They don't want to change that developer experiences, but they need the added advantages of Scalr in being able to scale this for multiple teams. So a lot of times we hear, we want to automate dry runs. Can we do that as part of Scalr? We don't have to build it. Or we want to automatically deploy the Terraform and the infrastructure on commits or merges, but we don't want to maintain the Terraform runtime environments due to whatever it might be. We don't want to deal with locking. We don't want to deal with run concurrency, whatever it might be. Also, a lot of collaboration. A lot of people come to us with collaboration issues. So you have multiple teams working on Terraform components, and you want to make sure that there's a governance framework in place. So you want to have automatic policy enforcements. You want to have RBAC in controlling so teams don't step on each other's toes when they're working on their Terraform deployments. And again, all of this they want to make sure they don't change the CI/CD pipeline, the existing pipeline they have in place. And that's really what we want to show you in this first demo that I'm going to show. So we're going to do the demo, give you a little bit of background on Scalr and why you don't have to change your existing workflow. And then we'll talk a little bit more about some of the benefits of Scalr. So what I'm going to do now is just flip over to command line. But what I'm actually, I'm going to actually jump into a workspace first. So what I've done prior to the webinar is I've created a workspace. The workspace in Scalr is the results of running Terraform. So you run a Terraform deployment that is all done in a workspace. That's where your state is stored. That's where your run history is stored. Pretty much everything and anything associated with that Terraform deployment is in the workspace. So quickly, just going to show you some of the workspace settings. All I've done prior to this webinar is create the workspace. I've linked it to a VCS provider, linked it to the repository, which contains a Terraform configuration file to create an AWS VPC. I've specified Terraform 14.19 as the version I want to use, and I've linked it to my main branch. You have the option to use different branches, anything that's in your repositories. You also can link it to subdirectories if you have more of that mono repo style. So you only want changes to execute, or you only want the Terraform to execute based on changes in a specific directory. And of course, you have the working directories. So what I'm going to do now is flip over to my command line. And what you'll see here is I just have a couple files here. So I'm just going to cat out and show you that we have in our main.tf, we have a configuration file that is just going to build a VPC. Nothing really special about it. Nothing needs to be changed for Scalr. It's your standard Terraform configuration file. So what I'm going to do is open up my Terraform.auto-tfrs, and we'll just go ahead and change this webinar to, let's call it webinar 1. Save that, and I'm going to go ahead and push it up to Git. I'll now flip over to Git, and we want to open up a pull request on this. So we're going to check against development, against main, create a pull request. And what that is going to do automatically using the Scalr and GitHub integration, and a side note here, we also integrate with GitLab, Azure DevOps, as well as Bitbucket Cloud and Bitbucket Data Center. But what that does, and this happens with any of the VCS providers we have, is automatically starts a few checks. So the first check it's going to start is making sure that the actual Terraform configuration uploaded into Scalr itself. The second check, which we'll see pop up momentarily, is going to make sure that it is it's going to run a dry run. So that dry run is checking, and it's already finished, is checking that what we expect to happen will actually happen when it goes through the core workflow here. So I'm going to open up that dry run, and what we're going to see is that it's going to go through the plan, cost estimation, the policy check, but it's skipping the apply in this case. So based on skipping apply, that's what we refer to as dry run. Everything looks good. I can come back here, everything's checked out. I can, if I only want to live in GitHub and I want a true GitOps workflow, all of the information I need is provided to me directly in here. And now I can go ahead and merge this pull request. As soon as I merge that pull request, I can flip over to Scalr, and now I want to go to the runs page for this specific workspace. Based on me merging that, we see that we already have a plan has started. And in this case, it's going to go through the full workflow, including the apply. So again, we're going to get that plan, cost estimation, policy, check, and then apply. So again, we have our standard Terraform output here. We now have the cost estimation, which is in this case, because it's a VPC, it's just $0. Our policy check, everything looks good, and I'll talk about this in a second, but we want to go ahead and approve this. And of course, you can have different approvers based on RBAC model. And while that's applying, I'm going to quickly talk about OPA. We're not going to talk about too much in this webinar. We'll have a separate webinar specific to OPA, as it's really a own topic. But Scalr integrates with Open Policy Agent, and really anything that is in this Terraform plan, you can download the JSON here. You can write an Open Policy Agent. You can write code for it and write policy checks for it. And it's not only Terraform plan information; it's information also around who's executing the run, what kind of run was it? Was it VCS based? Was it CLI based? What team has ownership of it? So there's a lot of different information you can write checks on to ensure that it's meeting your standards or passing your compliance standards. So in this case, we had things around modules, networks, instance types, all of those being checked as the JSON's coming through. So as you can see, we now have the apply. The resources have been created. And now what I'll do is just flip back into that main workspace dashboard. And now we'll see in the outputs page, we have all of our outputs. We have the state that can be shared now with other workspaces if we want to share that data, inputs, resources, etc. Full history of all the runs, as well as the full history of all states associated with this workspace. So that's just some of the basics around getting Scalr up and running. So I'm going to flip back here, and what we wanted to really show here is that Scalr has a very, very low barrier to entry. Really meaning if you already have Terraform code and you already have in your GitHub or GitLab or Azure DevOps repository, you're pretty much ready to go. So all I did was I created a workspace and linked it to a repository. I updated my code and committed it to the dev branch, and I opened and merged a pull request. So from my perspective, that's all I did. Scalr took over on the rest. So Scalr created that dry run for me and reported back all the information to GitHub. It executed the runs based on that merge. It generated cost estimation. It checked against my OPA policies. And lastly, it stored that state for me. Now that we have kind of the basics of how Scalr works, and we showed you some of the features, we want to dive a little bit into what is Scalr as a whole. So again, Scalr is what we consider Taco, the Terraform automation and collaboration software. But what else does Scalr provide? So we've talked about CLI and VCS. We've talked about OPA, which is one of our differentiators. One of our other differentiators is what we call our OPA previews. So an OPA preview really is, as an administrator, I might be making changes to a policy, say, to change a network, change my network standards. But I want to understand the impact that's actually going to have on my end users. So it serves two purposes. One, I can make sure that I'm not breaking anything. If I'm open up a pull request to change something with my network policy, I want to make sure I'm not breaking the entire environment. So that's number one. Number two, maybe it is a change that has potential to break the environment, and I'm okay with that. But I at least need to let my end users know about that. So you can open up that pull request. We'll generate that preview and that report. I now know what workspaces will fail based on that change to that policy. I can now give those end users a heads up that, hey, this change is about to go in about 2 weeks or so. Please make the appropriate changes. So that OPA preview is one of our main differentiators also. We also have RBAC, of course. So we have 5 built-in roles, but as of Tuesday, or starting Tuesday, you'll be able to create customized roles in Scalr. And also that RBAC goes with our hierarchical structure. I'll talk about a little bit from our account environment down to the workspace level. You, of course, can essentially store state files, and that results in also state sharing. We have locking of runs to avoid configuration conflict. This one, a lot of times we breeze over, but to be honest, this is one of the main issues that a lot of customers come to us with is, they come and say, we have a bunch of teams using Terraform. We have a bunch of users per team. And the problem is everybody's kind of stepping on each other's toes. We have configuration conflict. So this is one of the things that sometimes gets overlooked, but it's one of the critical components to building out this Taco software. We also have a module registry, and that registry supports either the monorepo style modules or a module per repo. Of course, cost estimation, and lastly, multi-tenancy, which I will talk about a little bit more here. So in Scalr, we have a hierarchical structure. And as I mentioned, RBAC, the RBAC model follows the hierarchical structure as well as many other things. So when you sign up at scalr.io, you sign up for an account. The account level, think of as more of an administrative level. At this level, you can create various objects like SAML integration, policies, module registries, VCS providers, catalogs, users, teams, etc. So many different objects you can create. Within an account, you can have one or more environments. An environment, think of as a logical way to group together multiple workspaces that relate to each other. So generally aligns to a team's function or an application team. I had a customer come to me yesterday and said they wanted an environment per network team, for the network team, for the storage team, and then for every one of the application teams. All of those individuals on each one of those teams need to collaborate together within those environments. And where this hierarchical structure really comes into play is that you can take all of these objects you create at this account level and then pick and choose which environments that they apply to. So you might have a production environment that has a specific policy. You might have 10 development environments that all share a different type of policy. You might have teams that share one or more environments. So it's truly a way to logically separate out teams, policies, and gives you a lot of flexibility for your organization. Now, while this is great, a lot of people come to us and say, love the environment, or the hierarchical structure, but how do I do this at scale? I don't want to go through it and do a lot of clicking. I don't want to do manual setup. Going through the UI is not exactly what we're looking for. After all, this is we're trying to get to a GitOps approach, or we're trying to do infrastructure as code. So why we should do this as code as well. And we agree. So managing Scalr should really be an afterthought in this case. So we have the Scalr Provider, Terraform Provider, which allows you to do everything that I just spoke about. So it allows you to create your environments, allows you to create your workspaces and link them to VCS repositories. You can hook up policies and credentials to your environments, create variables, and much more. So in this second demo, what I'm going to show you is how you use the Terraform CLI plus the Scalr Provider to really scale your usage of Scalr itself. So I'm going to have an administrative environment that manages all of my other environments. So as you can see here, I'm going to have this admin environment with an admin workspace. And the way this works, normally our customers actually describe this as kind of like a vending machine. They have maybe an administrative team that handles Scalr, and application teams might come to them and say, I need a new environment because I'm standing up a new application. Here's the name of it. Here's the repositories where my code is stored, and they're off and running. So as an administrator, that's all I really need to create these environments, create the workspaces, and link them to the repositories. And then those teams are autonomous, essentially. So what you're going to show you, as I said, we're going to create those environments automatically. We're going to create those workspaces, link them to the VCS and the shelf variables. Good. So what I'll do is switch back into Scalr again. And we're going to flip over to our Scalr Admin environment. So again, this is that hierarchical structure. I'm in the customer success account with these 4 different environments serving 4 different purposes. So in this Scalr Admin, I have this administrative workspace, which is going to manage the creation of other environments and other workspaces for me. As you can see here, I have these 4 environments. And at the end of this demo, what we should result in is an extra environment named Killer App with some workspaces within there. So what I'm going to do is flip back over to the CLI. And again, this demo is going to take the CLI approach. The idea behind this is to show the flexibility of Scalr. Again, our customer base is a 50-50 split between VCS based and CLI based. So before I execute the code, I'm just going to quickly show you part of the code. So first off, the only difference between running Terraform open source and using Scalr is that you just have to add in a snippet of code to tell Terraform that Scalr is going to be the remote backend. It's really the only difference between your existing code and how you need to use it in Scalr. So now that we've told it that it should use Scalr, I'm going to go ahead and we can just jump to run a Terraform apply. So as this apply is running, what we'll see is that it's going to call out that it's using Scalr as that remote backend, provide us a URL. While that's going, we'll come back to that. I'm going to show you a little bit about that code, the provider code that we're actually using to do this. So first step, we want to create an environment. So the environment's really where everything gets done. That's where the work actually happens. So we have the Scalr resource, Scalr environment. In that, we want to link it to an account. Do we want to enable or disable cost estimation, policy groups, and the cloud credentials all associated with that environment. Once the environment's created, we then want to create workspaces. The workspaces, what we have here, we're going to create a few of them. And we've declared, or we're using locals, so that really we're keeping the code dry here. And all of these different components here, you'll see that the code is very dry. And the idea is that we're going to be passing in these variables from our dev.tfrs and our prod.tfrs. So as customers come to us and they want these new applications onboarded into Scalr, all we're really having to do here is update and add a new file here, where we're adding in, what cloud creds should be used, what the VCS IDs, the policy groups, all of that information that's specific to that environment and that application team. So I won't go too much farther into this. We'll make this available after the webinar for everybody to dig into as they want. And we'll flip back over to here. So things are looking good. I'm just going to go ahead and approve this real quick and come back up to the top here where we saw that plan start. So we did that Terraform apply. It's telling us that it's running remotely, and it gives us the option to view this in the Scalr UI itself if we wanted to. We get the standard Terraform plan output as you normally would expect. And again, just a reminder, even though this is on my laptop, it's actually all executing in Scalr itself within a container. So this is all executing remotely in Scalr. So we've created the environments, we're creating variables, we're creating the workspaces. With the idea at the end of this, the environments, workspaces are all set up for the application team. We then entered the cost estimation phase, which of course doesn't cost anything because it's a Scalr provider. And then we have OPA checks. In this case, again, you can write anything. If the Terraform plan JSON has anything has information in it, you can write an OPA against that. So an example here is we're writing an OPA policy to limit environments. So you might want to limit on creation, on destroy. You definitely don't want to destroy an environment that is your administrative environment. So you can build controls around that to make sure that nobody potentially fat fingers something and accidentally destroys environments or changes environments that you might need. So we've now apply has completed, resources have been created, and if I jump back into Scalr, and we had those 4 here, if I do a quick refresh, we will now see we have this killer app one. So now I have 5 environments. If I click on killer app, we'll now see that it also created my 2 workspaces, linked them to my repositories. And now this team is essentially ready to operate. So it gave them their initial workspaces. They, of course, create more if they wanted to, but it's giving them the basics to get started. So if I click on this here, we're now kind of switching back to more of the GitOps style. And for timing purposes, I'll just come directly into here and just do a quick update. And we'll just change this to maybe a nano. and commit. And now what we'll see if I flip back to Scalr is that momentarily, or there we go, it's already in a planning state. So from an end user perspective, all I had to do was log into my workspace or log into my environment. My workspace was ready. It was linked to my repository. Just had to make a commit, and my code is now up and running. Again, very little needed on my end. So that's going to run through, and just going to jump back here, and we're going to wrap up kind of what we saw, and then we'll get into some Q&A. So just wrapping up, in entirety what we saw today in both demos. First off, Scalr is extremely easy to plug into existing VCS or CLI workflows with very minimal effort. As you saw, really, if you have Terraform code, either on your laptop or in VCS, there's not much you have to do in terms of getting it up and running. We have many different benefits of using Scalr. That ranges from OPA to our open policy agent to the OPA previews, to our hierarchical model that makes it very easy to have the multi-tenancy and to manage various objects and teams and business units. We have our CLI-based runs, all various differentiators from our different competitors. And then also we have what we call a template registry, which didn't necessarily show today, but I would encourage you to look at our docs, as that is one of our other differentiators. That is what we had to show today. So now I will open it up to Q&A. I'll just bring up the Q&A button here, and we can go ahead and start that Q&A. There we go. So first question is, are we going to introduce drift detection to detect when infrastructure goes out of band? This is a common request we get. We do have plans for this. The idea is it would be in two phases. First off, a lot of people come to us and say the first thing they want to do is understand when drift happens. Not necessarily auto remediate it just yet. They just first want to understand when drift happens. So that is in the roadmap. And then the second part of that is once users get a little bit more advanced, they then want to look into that auto remediation. So the answer is we are looking into that, yes, and that is part of the roadmap, and those two separate phases. Another question, let's see here. How do we handle if teams using different CD systems? How do we handle if we have one account but multiple teams having different workflows and different CI/CD systems? And the answer to that is that's through our hierarchy. So if I come back into Scalr and just quickly show you, I have a VCS integration set up here at the account level. But again, all of these objects can be shared across environments at the account level, or they can be created at the environment scope. So just because I have that VCS inherited from my account level doesn't mean I need to use it. I can create a new VCS provider in here specific to my team, or I can plug in my existing CLI workflow into this. So you might have some standards that you must follow, but at the same time, each one of these environments can have their own VCS integration, can have their own workflows, but from an administrator perspective, you can still enforce policies and RBAC and all of that sort of stuff on top of it. Next question, we have a question around how do self-hosted agents work? This is a great question. So self-hosted agents, essentially the use case, for those of you who don't know, the use case behind that is if you might have an API that is not public. So common use case actually is Kubernetes. A lot of people want to use Terraform to manage your Kubernetes, and the Kubernetes API is not necessarily public. So a common way to get around that is deploy what we call a self-hosted agent. So what that agent actually does is executes the runs for us. So it goes through this actual workflow in an agent where you've deployed in a location that you've deployed. So it can be behind your firewall, it can be really wherever you want. You're just deploying on a VM. And the way that this works is you can set up various agent pools. So when you set up the agent pools, really this is just giving you a one or two commands to run on your local server. And that communication is always going to be, so you run that in, install the agent, that's going to perform your runs. And the way that works is that communication is always going to be outbound from the agent back into Scalr. Scalr will never have to reach into your firewall. So a lot of times this helps a lot of customers that want to use SaaS but might have some security concerns. Self-hosted agents is really the solution to that, because it's always outbound communication. Scalr's never going to have to reach into that firewall. Another question we have, or two that are very similar. How can we run some CI steps in GitLab first before Scalr deploys? So depends on your workflow. So if you're using the GitLab VCS integration, the way that is going to work is that we are actually going to have the concept of pre and post hooks coming out very soon. So pre and post hooks give you the ability to download binaries, download various information or various steps that might need to execute before the runs happen or after the runs happen. Another option is if you already use a CLI workflow today. Some of our customers sometimes ask us that they might want to use checkoff before actually running Scalr. You can plug that into your existing workflow. Being that we have the CLI option, that gives you that added flexibility of just plugging in Scalr into that existing workflow and not really having to change anything whatsoever. But for that VCS-based approach, maybe in GitLab, that is where the pre and post hooks will come into play. Question on what's a pool. So we talked about the agent pools, and sorry, I should address this before. So a self-hosted agent is the actual agent that runs on a server, executing the runs. And what you can do is create different pools. So you can have 5 agents in one pool, 10 agents in another pool, and you can assign these pools to various workspaces and environments. So you can even do this at the account level. So the pools are essentially pools of agents that you can assign to workspaces and to various other components. Okay, next question. We already have automated Terraform testing using GitHub Actions with state and S3. What is Scalr giving me that I don't already have? So that is a good question. So a lot of that is those benefits we talked about. So, if you already have the automated testing in GitHub, it's likely something that you're going to have to maintain. And as I mentioned in the beginning, a lot of the customers come to us and say that we've already got this process. It kind of worked to us till a point, and now we're outgrowing it. That either can be due to run concurrency, that could be due to maintaining it at cost, but a lot of the added benefits of Scalr is, number one, you don't have to maintain it and you're not going to outgrow it. Number two is OPA is built in for you. We also have cost estimation built in for you. We have RBAC and hierarchy built in, the state, run history, auditing. So all of that is really built in for you already. And you don't have to do any more customization or extra work to get that into place. Just going back to Q&A here. Can you talk a little bit more about concurrency? So yes, so we hinted at concurrency, and that's another one that comes back to a lot, and that is, how can I execute multiple Terraform runs at the same time? That is one of the main issues actually that we come by on the do-it-yourself approach, is that the tooling that they put in place is great, but they're kind of limited to one concurrent run, or they try to do multiple and they kind of clash. So Scalr does have the ability to do concurrent runs, which means that you can have one or more runs executing at the same time within an account or an environment. So in our base tier and the free tier, I believe there's one concurrent run, and then the promo tiers and others, it goes up from there. But it gives you the ability to execute multiple runs at the same time. And I think that is the majority of the questions that we have. Any last minute questions? Doesn't sound like it. All right, so appreciate everybody coming and joining the first Scalr Terraform Automation and Collaboration webinar. We will be making this available, this recording available if you want to share it with your colleagues. Also, of course, feel free to contact me. My email is ryan@scalr.com. If you're not yet signed up, go ahead and sign up at scalr.com, and you can try out a lot of this. We do have the free version up to 5 users. And then, of course, one of our other differentiators that we normally talk about is our transparent pricing. We do believe that, pricing should be very transparent. So that is all on our website. What you see is what you get. So there should be no surprises whatsoever if once you signed up and wanted to maybe upgrade to a different tier. Thanks again, everybody, for joining, and we hope to hear from you soon. Bye-bye.